Start recording. Okay, I think I'm back in business, finally. So now we could graph this. I wouldn't have to, but if you have to for the first few of these that you try, no problem. So we have 0, 0, and then we'd have 4 is up here at 1200, like that. And then 8 would be up a little higher, and then 12 would be down here at 1000. And I could keep going. 16 wouldn't take much to keep going. 950, so it got a little lower, and even 20 is down here a little lower. So now we could connect this with maybe some, sort of smooth curve that we think, well, the runner's just not going to all of a sudden just accelerate quickly because they're running. So we assume that it's a nice smooth run, so it's a nice smooth curve. But we're going to estimate this is velocity, so this is feet per minute, and this is down here at minutes. So if we multiply the two together, we get feet. We get the distance the runner traveled. But we're going to use left endpoint. So there's the first left endpoint. It's at 0. Left endpoint, left endpoint, left endpoint, left endpoint, like that. So there's the rectangles that we're going to use to estimate. But they're all 4s. 4. So here's the first rectangle. So we have 4 by 0, because that's here's the left side. And then the next rectangle right here, this is the left side. So plus a 4 by 1200 plus a 4, there's 4 again. And we could factor out a 4 by 1230 plus, there's the next rectangle, base of 4. So 4 by 1000. And finally plus this one, which would be another 4 by 950. We can factor out a 4, of course. Let's do that when we're using the calculator. 4 by 0 plus 1200 plus 1230 plus 1000 plus 950. And we get, that's what I've been getting all day. So 17,520 feet is the distance the runner traveled. Now, mathematically speaking, that's called the displacement. But when we talk in terms of the context of the problem, I'm not going to say, hey, did you run this morning? Yeah, I ran this morning. Oh, what was your displacement? I'm not going to say that. I'm going to say, how far did you run? Oh, I ran about 3 miles or whatever it is. So in the context of the problem, this answer is the distance the runner traveled. Now, we could talk about it in more mathematical terms, but that's not how we speak with story problems. That's not how we talk. And so when you're putting it in the context of the story problem, we use more just how we talk every day. So it's the distance the runner traveled. Given that integral, use a graph to find the area under the curve and then find the average value of the function from 3 to 7. Now it says use a graph. We know how to take the antiderivative of that and find the exact answer, no problem. But I want you to use a graph to answer this one. So I'll be looking for the graph if this were to be on the quiz. It is. All right, so the y-intercept is 1. And if we plugged in 7, I'll have to go all the way up to 8. So 7 goes up to 8, and it's a line. X plus 1 is a line. But we're starting at 3. I notice we're integrating from 3 to 7, not 0 to 7. So 3 to 7. And this integral means area under the curve. That means area. So we need the area of this trapezoid. So the area of the trapezoid is 1/2. The base is actually going this way. 3 to 7 is 4. Base 1 is what we get when we plug 3 in. That's 4. And base 2 is what we get when we plug 7 in, and that is 8. Half of 4 is 2. 8 plus 4 is 12. So I'm looking at an area of 24. So it says find the area using graphs. And then it says another thing. It says find the average value. I kind of covered it up, but it says average value. Well, average value would be 1 over 7 minus 3, integral from 3 to 7 of x plus 1 dx. That's what average value would be over this interval of the function. Well, we already got this value. We got this value to be 24. So we have 1/4 times 24. So all we need to do is take our answer, divide by 4, and the average value is 6. So let's not reinvent the wheel. We already got that answer. We already did part of it. Let's use that answer. Everybody good? Very similar problem. An ant's velocity running across the floor can be represented by the velocity. Let's go in inches. So velocity inches per minute or second or whatever. Maybe we could even do seconds for an ant. They can travel pretty quick. We'll leave it as minutes. Evaluate the integral from 3 to 7 and discuss the mean of the value in the context of the ant. So we're not going to use graphs this time. It doesn't say to. So we're going to integrate from 3 to 7 of 2t minus 1 dt. And I'd rather do antiderivative if I'm given the choice. So minus t from 3 to 7. Antiderivative. So we plug in the top number, 49 minus 7. We plug in the bottom number, 9 minus 3. So 42 minus 6, so 36 inches. The ant traveled 36 inches from 3 minutes to 7 minutes. So that'd be the distance the ant traveled. Not necessarily, well, no, that's all I'll say. We'll expand on that later. I don't want to do that now. I don't want to confuse you for the quiz. Find the area under the curve of y equals x squared plus 4 from 0 to 2 using right endpoint values with 4 subintervals. So we're kind of bouncing between integral, which is antiderivative, which means the exact answer, and approximate answer. So this is actually once the approximate. We could integrate this from 0 to 2, and we could find an exact value, but that's not what you're asked to do. All right, so let's make a little sketch of this. We're up here at 4, and this is a parabola, so all we need is something like that. We're going from 0 to 2, but it asks for, I don't want to draw that line. It asks for 4 subintervals. So if you take 0 to 2, divide by 4, that means each of these bases should be a half. And we're using right endpoints. So right. These bases should be the same. I need to sync this. It's been messing up all day, so I should resync this because it's not quite exact. Anyway, well, all the bases are a half, so let's take out a half. Now we need right endpoints to get all of these heights. So we don't use 0. We start with a half. So 1/4 plus 4. There's the first one. Then I'll plug 1 in. 1 plus 4 is 5. Then we'll plug 3 halves in. That's 9/4. That's 9/4 plus 4. And then we'll plug 2 in because that's the very right one. 4 plus 4 is 8. So plus 8. So here, this is the first rectangle, the second, the third, and there's the fourth. So there's the 4 rectangles. Oh, here's what I would do. 9, 4 and 5 is 9, 13, 21 plus these two, that's 10/4, that's 5 halves. So 1/2 of 42 halves and 5 halves is 47 halves. I'm getting 47/4. Now that's an overestimate. That is not the exact answer, of course. That's too much. And we could find the exact answer for that, but that's not what it asks for. Grab your calculators. You should practice this, a couple times. So we'll find the answer to this. Now, the quiz says make sure you show your work on this stuff. And so I'll have points for the graph and points for setting up the integral, and then, of course, points for the answer. But I'm a reasonable person when I grade these. There's no work to be shown on this. This is see if you can get the calculator. So I would not expect to see work on this. 9.3 to 0.65. We're going to go, make sure you're in radians, especially if you are taking physics this year. Physics does everything in degrees. We do everything in radians, unfortunately. I wish we could, I wish we were doing the same thing, but we're not. Tangent of x divided by 3 minus natural log of x. And make sure you put the denominator in parentheses, because we're dividing by this quantity. And we have x there. Enter, and yep, that's what we've been getting all day, 0.049. So 0.049, no real work to be shown on that one. I get it. That's a pure calculator issue. Let's talk about this first one. Evaluate each integral, show your work. So I expect to see antiderivative. I expect to see values plugged in, even if you can do them in your head. And then I expect to see the answer. However, before we do that, let's talk about 1 over x. And you don't, of course, you wouldn't have to do this on your quiz. I'm just showing you kind of what, I need to make a point here. There's 1 over x. And we're finding the area from 2 to 5. So from 2 to 5 is somewhere right here. We're finding this sliver of an area is what we want to accomplish. If I went from, because this is symmetric, this is an odd function, from -5 to -2 should be the same area except negative. It would be negative area over there. But the same absolute value, same value, right? We can plug negatives into 1 over x. No problem. You can plug a negative into this all day. All right, now what's the antiderivative of 1 over x? What do we take the derivative of to get 1 over x? Natural log. We have a problem. Because I could, if I said this, the antiderivative is the natural log of x, if I was integrating from -5 to -2, we can't take the natural log of negative numbers. Try it on your calculator. It's going to give you an error. You can't do it. So the antiderivative of 1 over x is not natural log of x. It's natural log of absolute value of x from 2 to 5. Seems very trivial. Now, the argument you could make for me is that, well, we're integrating over positive values, so it really wouldn't be necessary. Yes, I understand that. But if I ask you, what is the antiderivative of 1 over x? It's the natural log of the absolute value of x. It has to be absolute value. Are there any questions on that? Was I clear on that? It has to be absolute value, even if we are integrating over positives. All right, anyway, and this is really why. So now we have natural log of 5 minus natural log of 2. I mean, I know I did the absolute value. Here it's fine just to put that. And then finally, if this was a multiple choice, then you would have natural log of 5/2. Like we talked about yesterday, minus goes to division with natural log. This is what I'm looking for. 1 point for the antiderivative, 1 point to show me that you've evaluated, and then 1 point for if we have to simplify the answer. Sometimes we don't. Any questions on how I'm going to grade these? All right, try the next one. And I would practice it like you want full credit for this. What would that look like? You can help each other out. You guys are so quiet. So there's probably a point. Doing the correct antiderivative. I think I got it right. Let me know if I don't get it right. Plug in the values. So we got 8 minus, let's see, half of 4 is 2, plus 4. Plug in 2 minus, plug in 1. That's 1 minus 1/2 plus 2. So I would accept that. You know, show me some values when you plugged the top minus the bottom in. 4, 1. Yeah, that looks good. Let's see. 6 plus 4 is 10. I mean, you can skip to the answer, but you know, if you got to work it out, you got to work it out. 3 minus, let's see, 3 is 6 halves minus 1/2. I'm getting 5 halves there. So 20 halves minus 5 halves, I get 15 halves. So there's 1 for the antiderivative. So 1 here. Show me the values. Show me the answer. If you got to do something in between, that's fine. That's fine. Everybody good? That's pretty much the quiz there. And I thought we could take some time to review for tests, or this could be on the quiz too. I don't think these are. So let's review for the test, shall we? On the first one, find K. This says we're not finding the area under the curve. We're finding what do we integrate to over this function to get the area to be 9 halves. Where should we stop? So here's what I would do. So we're going to integrate from 1 to k of x to the negative 1/3. And we want that to be 9 halves. You okay with changing that to that? Everybody good there? Yeah. I had a student this morning come up to me after notes were done, and it happened to be a girl. She said, how'd you do that? How'd you do that antiderivative part? Why'd you add 1? So I must have gone too fast, or I didn't explain it clear enough. So I'm going to slow down here a little bit. And I'm going to ask you, what's the integral of, let's go 4x to the 6th, dx. Let's do something that we have to think about a little bit. Now here's how I would do this one. I would add 1 to this, add 1, because remember we subtract 1 when we do the derivative. So antiderivative, we're adding 1, x to the 7th. All right, now what do we multiply times 7 to get 4? It's not that hard of a question. Well, what is it? 4/7, right? So that the 7s cancel and a 4 is left over. So we're going to multiply by 4/7. So that would be the antiderivative of 4x to the 6th. Everybody okay with that? So now we're going to apply it when we have this negative power here. And I'm sure for some of you, you don't have to go. I don't have to go this slow, but maybe for a couple, you need this. We're going to add 1, so we're going to add 3/3. Now that's x to the 2/3. That's exactly what we did down here. We added 1. Now the question is, what do we take times 2/3 to get a coefficient of 1 here if we were going to take the derivative of this? And of course that is 3 halves, right? The reciprocal. That'll get you the 1. Everyone good on that antiderivative? All right, very good. I hope that helped. I hope going that slow was good for you. But we just can't go that slow on everything. Equals 9 halves. I mean, really, I just did what I know what to do. That's all I know how to do. So that k, sometimes it looks a little confusing, but sometimes you got to just go, all right, what do I know how to do here? What have we gone over? And that's really the only thing we would know. And this is what you do. So then we plug k in. Minus plug 1 in, but that's just going to be minus 3 halves, because 1 to the 2/3 is going to be 1, and we want that to equal 9 halves. So 3 halves, k to the 2/3 equals 12 halves, which is 6. What does that say? 3 halves. Can't read my own handwriting. Multiply by 2/3, that's 12/3, that's 4. So when we multiply by 2/3, that's 4. And then we got to raise this to the 3 halves power. 3 halves. Now let's talk about 4 to the 3 halves without a calculator. I would definitely put this one on a calculator. You wouldn't need it at all. It's always better to do the root first. So I'll do the 2. The square root of 4 is 2. There, I did the square root, and 2 to the 3rd is 8. So k is equal to 8. So a little review of how we do fractional powers. Do the bottom first. Do the root first, because then you work with smaller numbers. You could do the power first. Anybody know what 4 to the third is? 64, but that's a little harder to do, right? And then what's the square root of 64? 8. So you'd still get 8, but it's always a little easier to do the root first, then do the power. You'll work with smaller numbers. Woo, Nelly. We're not going to do this one 20 more times. But I believe there's one very similar on the test. So you got to kind of remember that at the end of notes, sometimes we do test review. So I don't know how you're going to mark it or whatever you want to do. But we will not do this 100 more times. I want you to do this. Here's f of x right there. There's the question. Find that. Go. What do you do? Do you understand what they're asking? Yeah, go ahead.
On our sheet,
Yeah. Oh, yeah. It's to 6, isn't it? I fixed this earlier. Go to 7. Change that to a 7, you guys. Very good. Thank you. Go to 7. You probably already have the answer, don't you? That's what you get for going ahead. I'm teasing. Oh, you guys get it. You guys got it. I mean, you understand what they're asking. It's asking for area under the curve. That's exactly right. I see some people shading it in already. Excellent. Excellent. And I think all of us would break this up probably into something very similar. We're looking at a rectangle right there. We're looking at a triangle here and then a triangle here. But as you probably know, we got to make sure that we make this area negative because now we're below the x-axis. So this integral is an accumulation of area, accumulating positive then accumulating negative. 6 by 4 plus half of 4 and 4. And then minus half of 5 and 3. Oh, that's going to be odd. Bummer. 24 plus 8 minus 15 halves. So 32 minus 15 halves. I need 64 minus 15. 39? 49. 49 halves. So we just got to remember to subtract out that circle, that triangle that's below the x-axis. I know my shapes. I don't need to review. It's not a circle. Find the following without showing any work. That's an odd question. Now I don't want you to show any work. Well, you don't have to show any work. Do we know what x to the third looks like? What kind of function is it? Odd function, isn't it? Which means it's symmetric over the origin, right? Symmetric over the origin. So if you integrate from -2 to 2 over an odd function, what's your answer? It's 0. Now, if you're not seeing it, there's y equals x to the third, and I know you're going, well, you're showing work. Well, I don't have to. But if you don't see this, here is from -2 to 0, and then from 0 to 2 is the same area except positive. So this negative, that positive, they would cancel out, and that'd be 0. Sine is also an odd function. This answer would be 0, because you're integrating from -pi/2 to pi/2. Now, if we integrate from -7 to 4, that's not going to happen. But it will if you're going from -2 to 2. That'll cancel out on an odd function. Any questions on that? All right. This was backwards, so there's 2 corrections on the notes. That was this graphs that. I have them backwards on your notes. Yes, you see that? This is what it should be. Find the area of the shaded region which is enclosed by the x-axis, y equals 1 at the very top, and make sure you fix this equation so that it's proper, a parabola, upside down parabola. Well, here's the concept. If we take this rectangle here, we take all of this area, and we're to shade it all in. I think you know where I'm going with this, but maybe not. The area is it's hard to read, I know, it's a 2 by 1. 2 by 1. And if we took an eraser and we erased out the area under this curve, what would be left is the shaded region. So we're going to subtract out the area from 0 to 2 of 2x minus x squared dx. So there's the concept. Now you just have to finish the problem. 2 minus x squared minus 1/3 x to the third from 0 to 2. Antiderivative. Plug some values in. 2 minus 4 minus 8/3. And that is, if we plug 0 in, we get 0, so I'm not going to worry about that. 2 minus 12/3 minus 8/3 is 4/3. 6/3 minus 4/3 is 2/3. There we go. The last piece I think is very simple if you know what you're being asked. If what you're being asked, I think it's an easy question. I should probably say just true or false rather than which or true. So let's just go true or false. RAM from -2 to 1 of this function. So the approximation of the area under this function from -2 to 1, that's what this says. So this side is approximation, is greater than the integral from -2 to 1. Now the integral from -2 to 1 represents the exact value of the area under the curve. So in other words, if we use RAM, will we have an underestimate or an overestimate? Well, what we can do is just use one big rectangle. And it becomes, I think, very obvious. If I use that rectangle to estimate this area, is it an overestimate or an underestimate? Overestimate, clearly, right? Clearly, if you use one rectangle. So the approximation is bigger than the exact. That's true. The approximation is smaller than the exact. That's a false statement. No way. Well, now if we use RAM, and let's just say I used one rectangle for that, I think it becomes very obvious that that rectangle is a massive underestimate of the area. So the approximate is greater than the actual. That's false. The approximate is less than the actual. That's true. There we go. Whenever you see integral, you think, oh, they're talking about the exact area. Go ahead.
Will they ask us for the middle?
No, because it's too, you can't, it's hard to tell. So they won't ask about midpoint because it's a better approximation, so it's harder to tell. Yeah. I think that's it. All right.